In this lecture, I am going to present what are the different types of mechanisms found for failure of the portal frame and how to determine the plastic moment of a portal frame by kinematic method. Then I would like to solve two problems based on the portal frame. Then coming to the application of kinematic method to portal frame. The frame may fail by forming any one of the following mechanisms. The first mechanism, beam mechanism, the second one, sway mechanism, and the third mechanism, that is combined mechanism. So first we will discuss what is beam mechanism. The individual members of the frame may fail by formation of mechanism is called beam mechanism. This mechanism can take place only in the member with loads acting on its span. In a beam mechanism, 3 hinges are necessary, 2 at the ends and 1 in the intermediate position of the beam, that is under any one of the loading. If the end supports are simply supported, then in this case the end supports are considered as mechanical hinge, only the plastic hinge considered under a load point. Then what is sway mechanism? Due to lateral forces, a frame may sway considerably and form collapse mechanism. 2 hinges at the bottom and 2 hinges at the top of the column are necessary for this type of collapse. But if the supports are hinge support, so in this case hinge at bottom is taken as mechanical hinge, and in this case the work done is calculated by plastic moments acting only at the plastic hinge. Then what is combined mechanism? The combination of beam mechanism and sway mechanism is known as combined mechanism. In the combined mechanism, sway will be on the windward direction. If we combine the sway mechanism with beam, which can eliminate hinge at B, and at the same time work done is calculated by horizontal and vertical loads. So these are the 3 mechanisms that forming for failure of the frame. So the investigation should be carried out for all the mechanisms, and one which gives least collapse load or needs maximum plastic moment capacity is selected as real collapse condition. This can be determined by equating the internal work done by plastic moment at plastic hinge to external work done by loads. If the working load and load factor is given in the frame, the collapse load can be found by collapse load is equal to working load into load factor. Then coming to the portal frame, when both ends are fixed, so this is the portal frame, and this end is fixed and this end is fixed, and here this is the beam mechanism. These are the beam mechanism. Here these are the load is present on the portal frame. If these are the load present, so here due to this load one beam mechanism will be formed, and due to this load one beam mechanism will be formed, and due to this load one beam mechanism will be formed. So the beam mechanism due to this load, this is beam mechanism 1. In beam mechanism 1 there are 2 plastic hinges at 2 ends and 1 plastic hinge under the load, and in beam mechanism 2, 2 plastic hinges at the 2 ends and 1 plastic hinge under the load, 3 plastic hinge. And here in beam mechanism 3, here this is the load and this is end is fixed and this end is the intermediate joint. This is the intermediate joint and this is the fixed. So here 1 plastic hinge will be found, and here 1 plastic hinge will be found, and another plastic hinge under the load. This is 3 plastic hinge. So this is the beam mechanism 3. If there are 3 load is present, so you have to take 3 beam mechanism, that is beam mechanism 1, beam mechanism 2 and beam mechanism 3. Then the next mechanism, this is the sway mechanism. The both ends of the frame are fixed. So this case, this is the sway mechanism takes place. So here 4 plastic hinge will be found at the 4, that is this is the column and this is the beam. So here at the bottom of the column 1 plastic hinge, and at the top of the column 1 plastic hinge, and here this side also 1 bottom, and at the top 1 plastic hinge. If the ends are fixed, then this case the plastic hinge will be found at the bottom end here. So this is the sway mechanism. This is the combined mechanism. In combined mechanism, so this is the combination of the sway mechanism and the beam mechanism. Here for this load, this is the beam mechanism, and for this load, this is the beam mechanism. So in the case of combined mechanism, so you have to consider the sway mechanism plus beam mechanism 1 and sway mechanism plus beam mechanism 2. This is combined mechanism 1. So here you have to take the sway mechanism with the beam mechanism 1. In this case, so here there is no plastic hinge. At joint B there is no plastic hinge. Only the plastic hinge will be found at joint A, then joint C, joint D, and at the load point. This is combined mechanism 2. Here also there is no plastic hinge at joint B. Only the plastic hinge present at joint A, joint C, and joint D, and under the load point. These are the different types of mechanism takes place when both ends of the portal frame are fixed. Then coming to the portal frame, when one end is fixed and other end is simply supported. And this is the beam mechanism. Here end A is hinged and end D is fixed. So in this portal frame, the support A is hinged and support D is fixed. These are the different loading. Here also you have to take one beam mechanism under this load, another beam mechanism under this load, and another beam mechanism under this load. So under this load, this is the beam mechanism 1, and under this load, this is the beam mechanism 2, and under this one, this is the beam mechanism 3. But in this case, when you are considering the beam mechanism 1, so you have to take one plastic hinge here, another plastic hinge here, and third plastic hinge under this load. This is beam mechanism 1. And beam mechanism 2, in beam mechanism 2, you have to take one plastic hinge here, second plastic hinge here, and third plastic hinge under the load. This is beam mechanism 2. But in beam mechanism 3, so due to the hinge support at A, so here the hinge is your mechanical hinge. You have to take the hinge here, mechanical hinge. Only the plastic hinge is found at B and under this load. Only 2 plastic hinges you have to consider. So in beam mechanism 3, because here this is the hinge support, so this is the mechanical hinge. So here you have to consider the mechanical hinge. Only have to take the plastic hinge this end at joint B and under this load. This is the 3 beam mechanism which is found when one end is fixed and other end is simply supported. Similarly, in the case of sway mechanism, so due to the hinge support at the end A, so there is no plastic hinge. You have to consider only the mechanical hinge at support A, and at other point B, C, D, you have to consider the plastic hinge in the case of sway mechanism. But in the case of combined mechanism, here also you have to not consider the plastic hinge at the support A, only you have to consider here the mechanical hinge, and at joint B you have to not consider any hinge, plastic hinge. Here there is no plastic hinge at joint B. You have to take the hinge, plastic hinge at C and D and under the load. This is combined mechanism 1, and here this is combined mechanism 2. Here you have to take the plastic hinge at C and D, and another plastic hinge you have to take under this load, and there is no plastic hinge at B, and you have to take the mechanical hinge at the support A. Here there is no plastic hinge. So these are the different mechanisms when both ends of the support are fixed and when one end is fixed and other end is hinged. Then coming to the first problem, determine the plastic moment capacity of the section required for the frame shown in figure. The loads shown are the working loads. Take load factor is 1.75. Assume same plastic moment capacity for all the members. So this is the total frame, and here there is having one concentrated load on the span BC at a distance 3 meter from the support B or support C. That is, the load is present at the midpoint of the span BC, and this is AB. AB and CD is the vertical members and BC is the horizontal member. At the joint B there is having one horizontal load 40 kilonewton, and on the span BC there is having one concentrated load 80 kilonewton at the midpoint of the span BC, and the length of the span BC is 6 meter and length of the span AB and CD is equal to 4 meter, and end A is fixed and end D is fixed. This is the given frame with the working load. So here the working load is given and the load factor is given. First you have to find out what is the collapse load. But you know how to find out the collapse load? Working load into load factor. Here the working load is 80 kilonewton. So 80 kilonewton into 1.75 is equal to the collapse load. So this is equal to 140 kilonewton. Similarly, here present the 40 kilonewton working load into the load factor 1.75 is equal to the collapse load 70 kilonewton. So this is the collapse load 70 kilonewton. The horizontal collapse load is 70 kilonewton and the vertical collapse load is 140 kilonewton. And this is the frame with collapse loads. So here you have to consider the three mechanisms. The first mechanism is beam mechanism, second one is sway mechanism, and the third mechanism is the combined mechanism. So in beam mechanism you have to consider what is the load is present on the beam. So here only one load is present, 140 kilonewton load is present at the midpoint of the span BC. So this is BC and one load is present at the midpoint of the span BC. So here you have to take the plastic moment. Here 3 hinge will be found. Here 3 hinge will be found. That is 2 hinge at B and C, and the third hinge is found at the loading point. Third hinge will be found under the load. So this is the 2 hinge at 2 end B and C, and this is the third hinge under the load point, and the plastic moment capacity of hinge B is MP and plastic moment of hinge C is MP, and the plastic moment of hinge under this load is equal to MP. And this is the rotation takes place at B and C. So the rotation takes place at B is theta and rotation takes place at C is theta, because here the load is present at the midpoint of the span BC. So at both ends the rotations are equal, that is equal to theta. Delta B the virtual displacement under the load point. Here the rotation takes place theta plus theta, this is equal to 2 theta. First you have to find out what is the internal work done by plastic moment at the plastic hinge. At B the internal work done is equal to MP into theta, and at C the internal work done is equal to MP into theta, and under the load the internal work done is equal to MP into theta plus theta, 2 theta. So the total internal work done is equal to MP theta plus MP theta plus theta plus MP theta, this is equal to 4 MP theta. Then find out what is the external work done due to the load. The load here 140 kilonewton, and the external work done that you can find out by multiplying the collapse load with the virtual displacement. So the external work done is equal to 140 into delta. Then equate internal work done with the external work done. So here you got the internal work done 4 MP theta, and the external work done is equal to 140 into delta. 4 MP theta is equal to 140 into delta, but here you get the relation between the theta and delta. So you know here this length 3 meter and this is the angle theta. The virtual displacement delta is equal to 3 into theta. Then you put the value of delta here. Then 4 mp theta is equal to 140 into 3 theta. Then after cancel of theta, so you get the plastic moment is equal to 105 kilonewton meter from the beam mechanism. And take this is 1. Then the second mechanism, this is sway mechanism. In sway mechanism, these are the 4 hinges. So this is column and this is beam. So at the bottom of the column there is one hinge at A and the second is at B, top of the column. And similarly at the top of the column CD, one hinge C, and at the bottom of the column CD, one hinge D. So these are the 4 hinges which is found in sway mechanism at A, B and CD. And this is the virtual displacement at the B. So the same virtual displacement takes place at the point C. And this is the rotation at A. Similarly, the rotation at B is also same, equal theta. Similarly, at D the rotation is theta, and at C also the rotation is theta. And this is the plastic moment at A. This is plastic moment at B, plastic moment at C, and this is the plastic moment at D. The plastic moment is mp at A, B and CD. Then find out what is the internal work done due to the plastic moment at the plastic hinge. So the internal work done is equal to mp into theta. This is the plastic moment and the rotation is theta, mp into theta. And at B the plastic moment mp and the rotation theta, mp theta. And at C the plastic moment mp and the rotation theta, mp theta. And at D the plastic moment mp and the rotation theta, mp theta. So the total internal work done is equal to mp theta plus mp theta plus mp theta plus mp theta, 4 mp theta. Then find out what is the external work done due to the load. Here this is the lateral load present at B. So due to this load, find out what is the external work done. 70 into delta. This is the displacement, virtual displacement, and the load present here, the lateral load present at B is equal to 70 kilonewton. So here the virtual displacement, the external work done due to the collapse load 70 kilonewton is equal to 70 into delta. But we know this length, the height of the column is 4 meter and this is theta. So 4 into theta is equal to delta. Delta is equal to 4 into theta. Then after putting delta value here, so the external work done is equal to 70 into 4 into theta. Then equate the internal work done by external work done. So the internal work done is equal to 4 mp theta and the external work done is equal to 70 into 4 theta. 4 mp theta is equal to 70 into 4 theta. Then after simplification, mp is equal to 70 kilonewton meter. Then the third mechanism, combined mechanism. So here you have to consider the beam mechanism with the sway mechanism. You have to take the beam mechanism and sway mechanism, and here there is no plastic hinge, only the plastic hinge will be found at A, C, D and under the load point. So let us take the virtual displacement at B is equal to delta 1 and the virtual displacement under the load is delta 2. And this is the rotation takes place at A theta and at B theta, and at under the load the total rotation theta plus theta 2 theta, and at C the total rotation theta plus theta 2 theta, and at D the rotation is theta. So here you have to find out the internal work done. So due to this plastic moment mp into theta, here the internal work done, and here there is no plastic hinge, so here there is no internal work done, and under this load the internal work done is equal to mp into 2 theta, and at C the internal work done is equal to mp into 2 theta, and at D the internal work done is equal to mp into theta. Internal work done is equal to mp into theta at A, then at under the load mp into 2 theta, mp into 2 theta, then at C mp into 2 theta, mp into 2 theta, then at D mp into theta, mp into theta. So the total internal work done is equal to 6 mp into theta. then find out the external work done. So the external work done that you can find out due to this virtual displacement and due to this virtual displacement. So here the collapse load is 70 kilonewton. So 70 into delta 1 is the external work done at joint B, and under this load what is the external work done? So here the collapse load is 140 kilonewton and the virtual displacement is equal to delta 2. So here the external work done is equal to 140 into delta 2. So the total external work done is equal to 70 into delta 1 plus 140 into delta 2. Total external work done is equal to 70 into delta 1 plus 140 into delta 2. But here you see, so what is the relation between the delta 1 and theta? So here delta 1 is equal to 4 into theta, because this height of the column is 4 meter and this is the angle. So 4 into theta is equal to delta 1, and here the length of the BC is 6 meter and from this to this 3 meter. So here 3 into theta is equal to delta 2. Delta 1 is equal to 4 theta and delta 2 is equal to 3 into theta. Then after putting the value of delta 1 and delta 2 in the above equation, the external work done is equal to 70 into 4 theta plus 140 into 3 theta. Then equate the internal work done with the external work done. So this is the internal work done 6 MP theta, and the external work done is equal to this one. 6 MP theta is equal to 70 into 4 theta plus 140 into 3 theta. So after simplification, the MP is equal to 116.67 kilonewton meter. So here you got the plastic moment from the beam mechanism and from the sway mechanism and from the combined mechanism. So here you have to consider the higher value from the three mechanisms, that is beam mechanism, sway mechanism and combined mechanism, and this is the plastic moment capacity of the portal frame. So the plastic moment is equal to 116.67 kilonewton meter. Then coming to the second problem, collapse loads acting on the frame ABCD are shown in figure. Determine the plastic moment capacity of the section required. Assume the same section is going to be used throughout. So here this is the same section is used throughout the portal frame ABCD. So this is the vertical member AB, this is vertical member CD, this is the horizontal member BC. So on the vertical member AB there is given the uniform distributed load of intensity 10 kilonewton by meter, and on the horizontal span BC, so here given the uniform distributed load 20 kilonewton by meter. The support is hinge support and support D is fixed support. Length of the span BC is given 5 meter. The height of the vertical member is given 5 meter and the length of the horizontal member is given 5 meter. This is the given frame with the collapse load. Here also you have to consider the beam mechanism, sway mechanism and combined mechanism. So first coming to the beam mechanism AB. So here you have to take two beam mechanism, one beam mechanism for AB and the second beam mechanism for the BC. So due to this load you have to take one beam mechanism, and due to this load you have to take one beam mechanism. So first you take the beam mechanism in AB. So this is the AB, this is A, this is B, but due to the hinge support at A, so there is no plastic hinge, only here the mechanical hinge. Here there is no plastic hinge, only the plastic hinge will be found at B, and another hinge is your, that is 0.414 L from the hinge support. So one plastic hinge is found at B, and the second plastic hinge is found at a distance 0.414 L from the support A, because here you will get the maximum bending moment. The height of the column is given 5 meter. This length is equal to 0.414 into 5, this length, and this side the length is equal to 0.586 into 5. let us take the virtual displacement at the maximum bending moment section is equal to delta, and this is the plastic hinge, and the plastic moment of this hinge is your MP. The plastic moment of plastic hinge B is equal to MP, and here the rotation takes place at A theta 1 and at B theta 2, and you have to find out the what is the relation between the delta and the theta 1 and theta 2. So here you see, so this length is equal to 0.414 into 5 into this angle is theta 1. So 0.414 into 5 into theta 1 is equal to delta is equal to 0.586 into 5 into theta 2. This is the relation. 0.586 into 5 into theta 2 is equal to delta is equal to 0.414 into 5 into theta 1. Then from this relation, so you get theta 1 is equal to 0.586 by 0.414 theta 2 is equal to 1.415 theta 2. Then find out what is the internal work done. So here there is no hinge, so here the internal work done is equal to 0, and here internal work done is equal to MP into theta 1 plus theta 2, and here the internal work done is equal to MP into theta 2. So the total internal work done is equal to MP theta 1 plus theta 2 plus MP into theta 2. But here we know theta 1 is equal to 1.415 theta 2. So put the value here, then the internal work done is equal to MP into 1.415 theta 2 plus theta 2 plus MP into theta 2. So this is the internal work done, and find out what is the external work done. The external work done can be find out by multiplying the total load with the average distance moved. So the external work done is equal to what is the load is present, what is the collapse load is present on the vertical member. This here 10 kilonewton by meter, and the length is 5 meters. The total UDL is equal to 10 into 5. 10 into 5. Then what is the average distance moved? Here the virtual displacement is delta. So the average virtual displacement is equal to delta by 2. So this is the external work done due to the uniform distributed load. But we know delta is equal to 0.586 into 5 into theta 2. Here you put the value of delta, then the external work done is equal to 10 into 5 into 0.586 into 5 into theta 2 divided by 2. So this is the external work done, and this is the internal work done. Then equate the internal work done is equal to external work done. Then internal work done is equal to MP 1.415 theta 2 plus MP theta 2 is equal to 10 into 5 into 0.586 into 5 into theta 2 by 2. Then after simplification, MP is equal to 21.449 kilonewton meter. Then take the second beam mechanism in BC span. Here this is the BC span. Here there is having the uniform distributed load, and here there are 2 hinge will be found at the B and C, and the third hinge is found at the midpoint of the horizontal span. So here this is one hinge, plastic hinge, here the second plastic hinge, and the third plastic hinge is at the midpoint of the horizontal span BC, and this length is given 5 meter. Let us take the virtual displacement delta at the midpoint of the span BC, and due to the UDL, the rotation takes place at B is theta, and at C is equal to theta, and at midpoint of the span BC, the total rotation takes place 2 theta. The plastic moment capacity of plastic hinge B is MP, and at C the plastic moment capacity MP, and at the midpoint the plastic moment is MP. First find out the internal work done by plastic moment at the plastic hinge. So the internal work done is equal to, here the internal work done MP into theta, and here the internal work done MP into 2 theta, and here MP into theta. MP into theta plus MP into 2 theta plus MP into, so the total internal work done is equal to 4 MP into theta. Then find out the external work done due to the load. So the external work done can be find out by multiplying the total load into the average distance moved. The total load, that is equal to, So here the load is given 20 kilonewton by meter and the length of this span is 5 meters. The total load is equal to 20 into 5. 20 into 5 and the average distance moved, this is equal to delta by 2. Here this is the virtual displacement and the average virtual displacement is equal to delta by 2. 20 into 5 into delta by 2. And here we know what is the relation between the delta and theta. So delta is equal to 2.5 into theta. Then put the value of delta here. Then the external work done is equal to 20 into 5 into 2.5 theta by 2. Then equate the internal work done with the external work done. So the internal work done is equal to 4 mp theta and the external work done is equal to 20 into 5 into 2.5 theta by 2. Then from this relation find out what is the plastic moment. MP is equal to 31.25 kilonewton meter. So this is all about the beam mechanism in FB and in BC. Then coming to the sway mechanism. So in sway mechanism, here there is no plastic hinge due to the hinge support. So only the plastic hinge will be found at B, C and D. And this is the virtual displacement delta, and the plastic moment at B is equal to MP, and plastic moment at C is MP, and plastic moment at D is equal to MP. And this is the rotation takes place at A, B, C and D. So here find out what is the internal work done. So here there is no plastic hinge, so the internal work done is equal to 0 at A, and at B the internal work done is equal to MP into theta, and C and at C the internal work done is equal to MP into theta, and at D the internal work done is equal to MP into theta. So the total internal work done is equal to MP theta plus MP theta plus MP into theta, 3 MP into theta. Then find out what is the external work done due to the UDL. So here the UDL is given 10 kilonewton by meter and the height of the column is 5 meter. So what is the total load is present here? 10 into 5, and this is the virtual displacement. But here you have to take the virtual displacement as the load is present UDL, so you have to take the half of the virtual displacement. So 10 into 5 into delta by 2. Here you see the column height is given 5 meter and this is the theta angle. So 5 into theta is equal to delta. You put the value of delta here. Then the external work done is equal to 10 into 5 into 5 theta by 2. Then equate the internal work done with the external work done. 3 MP theta is equal to 10 into 5 into 5 theta by 2. Then after simplification MP is equal to 41.667 kilonewton meter. Then coming to the combined mechanism. So in combined mechanism you have to take the beam mechanism and the sway mechanism. So here due to the hinge support there is no plastic hinge, and at B there is no plastic hinge. Only the hinge is found at C, D and at the midpoint of the span BC. So this is the virtual displacement we given at the point B delta 1, and the virtual displacement we given at the midpoint of BC, this is delta 2, and here the rotation at B and C is theta theta, and here at the midpoint under this plastic hinge the total rotation is 2 theta, and here the rotation at C theta, and at D the rotation is theta. And the plastic moment here MP, and plastic moment at C MP, and plastic moment at D MP. Then find out what is the internal work done. So here there is no plastic hinge, so the internal work done is 0, and here also the internal work done is 0, and here the internal work done is equal to MP into 2 theta, and here the internal work done is equal to MP into 2 theta. Here the internal work done is equal to MP into theta. The total internal work done is equal to MP 2 theta plus MP 2 theta plus MP theta. This is equal to 5 MP theta. Then find out what is the external work done. The external work done can be find out by multiplying the total load with the average distance moved. What is the load is present here? Here the load is present UDL 10 kilonewton by meter and the length is 5 meter. 10 into 5 into delta 1 by 2. 10 into 5 into delta 1 by 2. And on the span BC, the UDL present 20 kilonewton by meter and the length of BC is 5 meter. So the total load is equal to 20 into 5 and the average distance moved, this is equal to delta 2 by 2, 20 into 5 into delta 2 by 2. So this is the external work done, but find out what is the relation between the delta 1 and theta and delta 2 and theta. So here this height is 5 meter and this angle is theta, so 5 theta is equal to delta 1, and here from this to this the length is 2.5 meter and this is theta, so 2.5 into theta is equal to delta 2, 2.5 theta is equal to delta 2 and 5 theta is equal to delta 1. Then put the value of delta 1, delta 2 in this expression. After putting the value of delta 1 and delta 2 in this expression, the external work done is equal to 10 into 5 into 5 theta by 2 plus 20 into 5 into 2.5 theta by 2. Then equate the internal work done with the external work done. So the internal work done is equal to 5 MP into theta, and the external work done is equal to 10 into 5 into 5 theta by 2 plus 20 into 5 into 2.5 theta by 2. Then after simplification of this expression, so here you get MP is equal to 50 kilonewton meter. So here you got the plastic moment from the 4 mechanism, 2 beam mechanism, 1 sway mechanism and 1 combined mechanism. Out of these 4 mechanisms, you have to select the plastic moment capacity of the frame, which one is the higher value. The higher value considered as the plastic moment capacity from the 4 mechanism, that is 2 beam mechanism, sway mechanism and combined mechanism, and the highest value is the from the beam mechanism. From the beam mechanism 1, 21.449 kilonewton meter, and beam mechanism 2, 31.25 kilonewton meter, and the sway mechanism 41.667 kilonewton meter, and from the combined mechanism 50 kilonewton. So you have to select 50 kilonewton meter is the plastic moment capacity of the portal frame. So MP is equal to 50 kilonewton meter. This is all about the determination of plastic moment of the portal frame by considering the 3 mechanisms. First mechanism is beam mechanism, second mechanism is sway mechanism, and the third mechanism is combined mechanism. So out of these mechanisms, the higher value is taken as the plastic moment capacity of the portal frame. Now all are clear.